The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, everyone. Welcome to the first part of this two-part webinar series. As you all probably already know, we NXP have partnered with Amazon Web Services to tell you how you can leverage Amazon FreeRTOS with NXP's MCUs for your next IoT design. For the first part today, we're going to be kind of giving you an introduction to Amazon Web Services IoT and Amazon FreeRTOS, as well as the concepts and benefits of using it together with NXP's LPC MCU family. Before I kick it off and hand it off to Brendan, do know that there is the handout where you can find the slides for this part. It's a PDF, so you can download those. And then there's also a question box on the right-hand side where you can ask questions. We do encourage questions because we do want to answer your questions. And then afterwards, we'll have a recording and the slides up as well. We'll upload them and we can share that with you. But we look forward to having you for the rest of the webinar. And that being said, I'll hand it off to Brendan.
Thanks, Ethan. Hello, everybody. My name is Brendan Slade. I look after the ecosystem and partnerships for the LPC product line here at NXP. With me today is Anton Schmagin, who's a partner solutions architect from Amazon. We're very pleased to have him here, and he'll be doing most of the talking for today. As Anton's presenting, I'm going to ask him to press the buttons for me. So I'll ask him, Anton, would you mind if we move on to the agenda?
Hello, everybody.
Thanks, Anton. So I'll do a very quick introduction to NXP at a high level about our microprocessor and microcontrollers before introducing some of the ideas around cloud connectivity and quickly handing on to Anton. He's going to look at applications and challenges that Amazon and NXP are partnering up to solve, and then getting into more details on Amazon FreeRTOS and the AWS IoT suite of services. We're going to look at the LPC 54018 IoT module-based boards that go with it, and then Anton's going to be running a demonstration. So if you have questions as we go, as Ethan said, please type them in the questions box. We'll probably deal with most of those at the end. I may jump in with your question for Anton as we go. So let's move on to the next slide. So NXP, well, NXP has a long history in the innovation in the microcontroller space. So we were pioneers of ARM cores in the general purpose space with the first flash-enabled devices, and we've continued to bring those innovations in peripherals, architectures, and process technologies into the market. We also bring together products from our microcontroller business with other NXP products and integrate those with software to complete reference solutions. So that's the first of our 5 pillars, we say, that underpin our microcontroller products. So we offer low-cost boards, software, and tools. We were pioneers, again, of the MCUXpresso, very low-cost board and free tools, very high-quality free tools, and they've evolved into MCUXpresso that we'll just touch on later. We have a very strong market presence in automotive, and that kind of DNA of quality just filters through to all our products. And another reason that you can feel comfortable with designing in our products is the longevity programs that we have. So most of our products are 10 to 10 year are in our 10-year longevity program. Some go to 15 years or even more. We have great local support through our worldwide distribution partners, and also they are backed up by our NXP staff in the field. And then we have a very strong partner ecosystem. So we focus on leaders in technologies such as software tools, middleware, and other software, and in emerging technologies like cloud connectivity and security. And so Amazon is an obvious partner for us to be working with in the cloud space, and we're very happy to be doing that. So next slide, please, Anton. So this slide's to represent where NXP microcontrollers are seen today, where they're being designed in and manufactured, where those products are being manufactured. And you can see it's a very broad space. Automotive isn't shown here. We have automotive as well. That's under a different business structure, but it's still very much using the same kind of DNA of our technology that I mentioned before. So you can see we go all the way from general consumer through gaming and home and building, industrial and general embedded spaces. And you can see household names throughout our portfolio. So we have over 10,000 customers between the LPC product range Kinetis and IMX-RT is a up and coming technology that's extremely popular. So in the next slide, we can see how one of the strengths NXP has is its portfolio that ranges right from tiny little MCUs in our LPC 800 series all the way up to quite an amazing technology in these multi-core layerscape processors. And in between we have various products from the Cortex-M range up to the Cortex-A class devices, and including graphics, audio, DSP acceleration, vector processing spread across the appropriate devices in that family. And what this picture is representing is as the Cortex-M MCUs, the microcontrollers are going up and up and up in capabilities. We see the IMX-RT devices at the top end of that. They're starting to meet the point where the application processors coming down from the other end, which are going down and down in power consumption, are starting to hit the convergent point. So the great news for the customer is whichever direction you're coming from, whether you're an embedded Linux kind of developer or whether you're a bare metal or FreeRTOS type developer coming up from the microcontroller end, at neither end are you having to give up the platform you prefer in order to keep developing into the space you need to. So let's move on to the cloud and the main subject of our talk today. So if we look at the vertical markets that are most prevalent in the cloud connectivity space, if you like. So we have smart home, industrial, automotive metering, and all of those are areas that were covered in the slide a few moments ago. So you can see that the product portfolio aligns very well with that. And then the last slide for me, looking at how we get into cloud connectivity with these. So as always, time to market's a challenge, and while many markets in many markets, cloud connectivity is still very new. Companies can't afford to be complacent about it coming and get to the market too late. The functionality required for cloud connectivity is quite extensive, and so complexity is a real challenge. And along with that comes associated development costs. And of course, once the solution is deployed, you have to make sure that it's cost effective to operate and is competitive. So cloud connectivity promises many added benefits or themes as well, including enhanced consumer convenience such as smartphone control, real-time control, which brings its own challenges depending on network latencies and so on, remote access and monitoring. And the explosion of the connected devices leads to exponential growth in the data, which of course leads to a lot more compute power being required. And of course, everything needs to be properly secured. So at this point, having laid out some of the challenges, I'm going to hand to Anton, who's going to explain how Amazon Solutions in partnership with NXP can help solve those. So Anton, over to you.
Thank you, Brandon. Hello, everybody. As Ethan and Brandon mentioned, I'm partner solution architect, so I'm working very closely with NXP in order to evangelize the solution. And today we'll take a look on the entire ecosystem of IoT services that AWS provide, but we will concentrate probably the most on Amazon FreeRTOS. This is the newest addition to our portfolio. It was kind of secretive project for a year when we took over the open source FreeRTOS project and we're governing. That being said, it is remain open source. We're committed that it will remain open source. To show the willingness to work with the community, we actually even lowered the licensing. So instead of GPL version 2, it is MIT license right now. So it's very non-restrictive license, and we also not pushing you to use AWS. We would prefer you to use AWS, but obviously it's an real-time operating system that you can basically use to power your design, and also connect even to your local, let's say, IoT brokers, MQTT brokers, or some other IoT endpoints. So this is not what AWS provide. This is just a subset of IoT services, and we'll dive in and go from the left-hand side to the right-hand side, from what we call edge to the analytics in a cloud. So two products at the edge side is basically the Amazon FreeRTOS, which is primarily covering the low power microcontrollers that often need to run on a battery, so that they have to go on a deep sleep mode. And AWS Greengrass is more oriented on kind of embedded Linux type of solution, and even more, because it is containerized solution that isolates, to a certain extent, it isolates hardware from your runtime code, making it very easy and making it very easy to do the secure updates without risking to break your hardware in the field. So let's dive to the FreeRTOS first. FreeRTOS is very mature operating system, and what we extended in Amazon FreeRTOS, we extended FreeRTOS kernel with several libraries. It is connectivity library to make it easy to connect embedded solution to the cloud. We also been very in Amazon, it's basically job zero for us. Security is job zero for us. So we concentrating on secure connectivity. So the only way to connect to MQTT broker in AWS is using the TLS 1.2 with mutual certificate authentication. We've seen numerous times that updating the devices in the field, it's a pain point for our customers. So we're tackling that aspect, and obviously something very specific to how AWS operates at the edge. Obviously, we're providing the libraries for AWS Greengrass, the most left-hand side box, and the Greengrass is our edge, as I mentioned, is our edge devices, edge gateway devices, I would say. So FreeRTOS is very popular operating system for microcontrollers. Basically, the openness and this very conservative approach that Richard Barry, original author of FreeRTOS, been practicing for years, made it compelling. Made it very compelling choice for many embedded developers and also companies alike. By providing the standardized libraries that we've seen numerous times, it's actually not easy for embedded developers to use and to adapt to the cloud. This is a huge differentiator. It's basically makes the time to market much faster, and it also provides this baseline of quality for this type for the connected IoT connected solutions. Partnership with NXP is also provides us in Amazon the tremendous opportunity to leverage these huge ecosystem that Brandon was talking about, from the tiny microcontrollers to the very powerful to very powerful application processors. So until that point that you've seen on the slide before, so the Amazon FreeRTOS can run from the LPC and Kinesis families up until RT1050, and then for the application processors, we also have a numerous solution that can run the AWS Greengrass. As I mentioned before, providing the quality control for all these libraries gives our customer an assurance that this solution gonna work seamlessly. And I'm not saying that all these libraries are perfect, but the open source nature gives us this leverage that if the library is let's say not performing properly or misbehaving, we're getting early notification from the community, and it's very easy fix for us. So basically, by giving the exposure to the wide community of developers, the quality is going up. But as I mentioned before, the primary focus is to have these kind of building blocks for the developers that can be leveraged in order to provide a quality solution and drive the time to market much faster. Currently, we at our reInvent conference last year, we released just 4 microcontrollers, but we're working very actively to qualify additional boards to the for Amazon FreeRTOS. But the open source nature doesn't prevent you to take and do the porting yourself. So we've seen very active participation from the community, and we've seen already numerous solutions that basically uses the FreeRTOS kernel and Amazon FreeRTOS on the platform that we haven't qualified, let's say, officially. Connectivity to the Greengrass, I will probably omit a little bit just to save the time. But Greengrass allows to provide the local connectivity, and it's a very cost-effective solution, because let's say if your sensors and your actuator need to talk locally without sending all the messages all the way to the cloud, obviously you're saving a lot of money by leveraging the messaging and also compute at the edge. In AWS IoT Core, we supporting several protocols. Primarily is MQTT with TLS 1.2 and mutual certificate authentication for the devices. For the mobile devices, you can utilize the MQTT or WebSockets, and also we have the HTTPS connectivity option, but primarily for the control tier, not for the messaging tier. And the only 2 protocols providing like a real pub/sub connectivity, publishing subscribe connectivity, is MQTT and WebSocket. We trying to provide the abstract layer for security, and as we can see, we're providing libraries for the TLS 1.2 connection, and the moment the TLS 1.3 gonna be standard, we're gonna be supporting that as well. What is also interesting, we're providing the PKCS 11 interface for the key management. Obviously, PKCS 11 is very broad standard. So for the microcontroller, we're providing only subset of the PKCS 11 standards, but the subset of APIs allows us to integrate with a secure element, trusted execution environment, some embedded HSMs very easily, or even the let's say the TPM solution. Right now, the providing the updates for the connected devices is mandatory, and we see more and more regulation and basically compliance regulation that demand that, while sometimes it remains black magic for many customers and companies, and very often the updates, we've seen that it's afterthought during your development phase. So we're trying to educate our users, and we're trying to provide the over-the-air update libraries that would allow customers very easily manage their fleet of deployed devices in the field in a very secure way. We're providing the firmware's verification. I mean the signature verification. We're also providing the kind of tooling for signing. But if you already have a solution, or for example, the vendor providing the solution for firmware signing or encryption, we can pretty easily integrate with those solutions and build upon as well. So let's talk a few slides about AWS Greengrass. So the whole idea behind our Greengrass offering was that we've seen after 2 years of operating AWS IoT service that the cloud cannot be 100% answer for all use cases. So and we kind of concentrated on 3 pillars that or 3 laws that we cannot avoid. We cannot just blindly say it's fine. So first of all, we cannot beat the speed of light, and this is the law of physics. So basically, when your device, when your connected device talking to the cloud, distance matters, and your latency is directly proportional to the distance from your endpoint. And for example, if you need an extremely fast reaction from the and dispatch, let's say, some reaction from one sensor to the actuators, sometimes holding it through the cloud is not an answer. The another one is law of economics. Although AWS MQTT broker is extremely cost effective, and you basically paying pennies for million messages, right? It still costs you money. right? So by providing this opportunity to dispatch messages locally, obviously a lot of customers they can save quite substantial funds. And finally, what is becoming really important is the law of the land, where the compliance regulation demanding that, for example, certain information cannot leave a territory, or certain information cannot leave on premise and be stored in the cloud without tokenization or encryption. Think about HIPAA regulation for the patient data, or think about PCI compliance, or for example GDPR standard in Europe right now. So the Greengrass providing number of components that obviously simplifying, but just not to bore you with this slide, if you can take from this presentation one thing, that would be Greengrass completely changing the velocity how the embedded developers interacting with the devices. So typically what was happening that the firmware was developed, tested, and then updated to the devices. What's happening in this case is that everybody probably standing on their toes when this 1 million of devices is going through this rolling update, right? Greengrass allows you to test your compute function, your compute atomic operations. We call them lambda function. You can develop and test them in the cloud, and then push them to your fleet of the Greengrass cores. And it's a very non-disruptive process. So for example, even if you made a mistake, the isolation and also isolation between your compute logic and your update control plane allows you to very quickly to redeploy this faulty lambda function. So right now I don't have a fear how I develop my solutions, because I can deploy very quickly, and I can use similar tools that cloud developers been using for almost a decade right now. Because what's happening is that I can put the entire CI/CD pipeline with the all checks, all unit tests, and I can streamline my development, and I can speed it up tremendously. So moving to the cloud side of AWS IoT suite of services. AWS IoT Core, this is first service that we unveiled several years ago, almost 3 years ago. And it's a very robust and very, very scalable MQTT broker in the cloud. So we literally processing the billions of connections with sometimes trillions of messages. And the architecture is designed that we can literally scale very quickly and accommodate multiple clients with these potential spikes without any degradation in performance. I can go really deep into the architecture, but if you're interested, just make it in the we can talk at the end of this session. So several the AWS IoT Core has several components. So MQTT broker is, as I mentioned. We also have a what we call a rule engine that allows you to select, transform, and route your messages very quickly. We have a shadow interface that allows you to represent your physical device state in the cloud as a virtual state representation in the cloud. Just to give you an idea, so for example, it basically make it possible to decouple the control logic for the intermittently connected devices. For example, your device going to the deep sleep mode, it cannot miss the actual MQTT message, but using the shadow interface, the moment it wakes up, it sees that the desired state of me as a device is changed, and updates its state accordingly, and signal back to the cloud that right now my reported state and my desired state is converged. Think about like the color LED lamps that I would like. So let's say my state right now has to be light green, and obviously the lamp can adjust its state and report back the moment it's adjusting its state. Obviously, the entire suite and the entire the core component of AWS IoT integrates with variety of AWS services. We can do the federation. So MQTT with mutual certificate authentication, it's a very strong identity, right? Especially if you're using some hardware rooted. I mean the trust that rooted in hardware, and we can leverage that to federate between this MQTT identity, right, and very short-lived tokens to any service that AWS provides. So, for example, if you would like to stream the video and use the recognition service in AWS, you can do it from your literally tiny microcontroller by connecting to AWS IoT. MQTT probably not the best channel to stream the video, so you can use something like Kinesis. But in order to have Kinesis, in order to talk to the RESTful endpoint for Kinesis, you need to have some API key and secret key, and we can very quickly generate this on the fly based on your MQTT identity. Very often, this is the point of confusion for the people. So in this slide, I very quickly outline the relationship between the certificate thing and policy in AWS IoT. So in order to even initiate connection to the MQTT broker, you need to have your private key and certificate, and this is basically the top part. However, you can initiate the connection, but if I don't have a permission to connect, I would not be able to finalize this connection. So basically, I need to attach policy to my certificate, and policy is a very granular. We have a very granular syntax of what you actually can do overall in AWS, but particularly for IoT connected devices, you can specify if I can connect, when I can connect, for example, that I allow to publish to certain MQTT topics, and those, as you can see, that can be dynamic, because right now I can only publish to the topic that is correspondent with my client ID. In this particular example, I can subscribe to any topic, but obviously in production you have to limit it to certain topics. And finally, your certificate can be attached to the thing, and thing is a virtual representation of your physical device. So it has some static attributes, for example, the serial number of your device, vendor, anything that is not changing often. And it also has, as I mentioned, it has a shadow, which is the state of your device at this current moment. And I can off-band, I can change the desired state of my device versus my reported state. You've seen on the slides before, I was talking about rule engines. So in this slide, I'm showing how it actually look like in the console. So we're providing the SQL-like language for querying this structured JSON payload that your endpoint devices can that your connected devices can send to the cloud. So in this case, I'm basically selecting one of the attribute. I'm selecting the whole sensor reading from the topic LPC 54018 demo, and I only want to act and store these messages if the reading of my hold sensor is above 4096, which is basically like a 12-bit reading. IoT device management, it's relatively newcomer. We've been doing the onboarding and management in AWS IoT Core, but we branch it out right now and develop totally new capability of bulk provisioning and very granular management and also update capabilities for your fleet of devices. So, for example, if you have your customer, the fraction of the customer that you know responding very quickly and very objectively to new to let's say to updates in the device logic, you want probably to roll out the new firmware to those customers first. So you can specify the groups for the updates or for certain let's say service to service some of your devices in the fields. You also can manage like a rolling update. So for example, if you vacuum cleaner, if you have a connected vacuum cleaner, you probably don't want to update its firmware when it's doing the cleaning, but most likely in any time zone, nobody doing the vacuum cleaning in the middle of the night. So probably it's safe to do the firmware updates around, like 3 a.m. to 4 a.m. Device Defender is currently in the active development, and Device Defender allows to baseline your device policy and kind of audit, do the ongoing audit for your device policies to see if something changed or there was a malicious intent to make it much more permissive. We also gonna be providing a capability to audit and do the anomaly detection for live connection from the devices. So, for example, if you see that we have certain deviation from the baseline for for your fleet of devices. You can notify, and you can even very quickly act to block such devices and do the further investigation, or basically notify your security officers and do the ongoing investigation. And finally, the AWS IoT Analytics is a tool that allows you to massage your data before you're even going to be kind of putting it into some higher level analytic services in AWS, for example, EMR or machine learning, or something like a SageMaker. It allows you to slice and dice your data, also do the very quick visualization, and build a model very quickly, just right from the Python notebook. And you can do the visualization, for example, through AWS QuickSights, very quick and easy, without even sending the entire data to the other AWS services. As I mentioned before, security is very important to us, and that's why we are super happy that NXP sharing this vision, and we have a number of solutions that allows not only secure deployment, but it's actually also simplify and streamline the deployment of solution, the order of magnitude from how you can do it, let's say, manually. And one of the option is to use the NXP A71CH crypto chip, and you can pre-provision those chips with the security credentials, with a public-private crypto pair and certificate in a very secure environment, like NXP manufacturing line. Then you can ship those crypto elements to the device manufacturing, and you don't need, in this case, to worry that your device credentials somehow can be stolen or leaked, because these crypto elements, they typically originating from the payment industry. They error prone from the majority of hardware attacks. So let's say fuzzing and glitching, and let's say the sledgehammer type of attacks. The another solution that we're actively working together with NXP is to use physical unclonable function, and that is a really incredible approach of securing your storing your keys securely in the microcontrollers, based on imperfection of your of silicon production. So basically, believe it or not, every region of SRAM that been manufactured currently, and it doesn't matter which nanometer technology you're using, it still has in uninitialized state. It acts almost like a fingerprint, like a human fingerprint. So you can uniquely identify the particular crypto chip based on an uninitialized array in your SRAM. And paired with the just-in-time registration that we provide in AWS, it's a very easy and streamlined process. So basically, you provision your crypto elements in a secure facility, device manufacturing, reflowing it to your PCB. It comes to the end customer the moment the device is ready to onboard. So let's say the user put the Wi-Fi credentials to it, device kick in, and initiate connection to AWS MQTT MQTT broker, which puts the device in a pending state. I'm verifying that the certificate is coming from the certificate authority that I trust, and through the Lambda function, I'm on the fly updating the updating the state of the certificate, that it's in active state, and I also updating the policy that attached to the certificate, which makes a very easy way to onboard the device. It's extremely easy to basically program LPC, and not only LPC, it's the Kinetis family or RT, IMX RT family, using the MCUXpresso. Obviously, for me, this is preferable choice. I'm using Macintosh, as you can see, and it's a multi-platform tool. I want to very quickly show you how you can download SDK, for example. For example, here I have the SDK for LPC 54018. You will see it later in a demo, but basically you're registering to MCUXpresso SDK builder, and you can basically cater the SDK. You can very easily update SDK for your particular family of microcontroller, or even particular board. In this case, I mean, we see that I have a specific SDK built for my LPC 54018 IoT module. It's actively developed, and we're extremely happy to see that right now the Amazon FreeRTOS is integrated into this environment, and you can very easily just decide, okay, I would like to use the standard Amazon FreeRTOS using the AWS demos, or I can kind of slice and dice it. I would like to use this library from Amazon FreeRTOS, and I would like to use, for example, LWIP for my IPv6 connectivity library. So it's very flexible in MCUXpresso to build a project that is targeted, basically targeted for your particular solution, which obviously saves the memory footprint and all this stuff. That being said,
Anton, I just wanted to mention on this slide is I forgot to make sure we had on here that IMX RT is also supported by MCUXpresso SDK, because I know a few people have been asking about that. So sorry to interrupt. Just wanted to make sure people knew that.
Yeah, I think I mentioned it like previously, that yes, IMX RT family is supported, and it's already Amazon FreeRTOS ready, but it's going through the through official qualification between NXP and AWS. What is also I should mention that MCUXpresso is not the only IDE that you can use to develop the solution for Amazon FreeRTOS for the NXP families, the AR and Kale, and basically generic GCC toolchain. I mean, IDEs and toolchains are available. So if you already invested in IR or Kale, there are no need to change the IDE. But if you're just starting, I think this is really powerful IDE to use. Very quickly, as as Brandon mentioned, you can see that here you already have the IMXRT1050 support, and we're actively working to bring these new models for the LPC family and for the Kinetis family and IMXRT families. This is how the module LPC 54018 look like. It's very tiny. I really like it. I think it's also very low cost for the caliber. I mean, it's extremely high quality, low cost, and very performant processor Wi-Fi combination. And it has a tremendous support from NXP, from Embedded Artist. It's the company that was partnering with NXP to develop this board, and also from AWS. It's very Spartan as a module. You will see it. So pretty much you can test your connectivity. You can probably use the internal temperature sensor, and there are one user LEDs. But if you would like to test your solution, you can obviously need some baseboard. So currently 2 baseboards available. One is with obviously all bells and whistles, including the LCD, like gorgeous LCD screen, and it's available right now from NXP distributors or even Amazon.com for $149. And there are the new mini baseboard with micro E sockets that is available as of now. Brandon, correct me if I'm wrong, and it's very low cost solution.
Yeah, correct. The mini baseboard, just if you could flip back one slide, Anton, if you don't mind.
Yes.
The mini baseboard, we just got stock on that, so it's just making its way into our online store and into our distribution channel. So we are actually gonna, in the registration link, you would have seen that if you attend both of these webinars, we'll be giving out a coupon code in the next one. So that will give you 50% off the IoT module and the mini baseboard. So if stock isn't there when you look, check back, it will appear there. If you can't wait, then the module's available from Amazon US right now, and it's also in several of the NXP distribution channels as well.
Wow, that's amazing. And needless to say, the micro E sockets, the click socket, is providing you with, I think right now, roughly 450 expansion. Basically anything you pretty much can imagine. The ADC converters and cellular radios, and I mean, it's very professionally oriented. This is not like the cheapest modules, but they typically very high quality and tested really well before entering that.
And
okay,
sorry, Anton, I did want to just mention it. It's on that mini baseball line. I kind of Embedded Artist designed it for us, and I'm pretty excited about the module because it actually has this couple of neat features that aren't visible in the picture. So there's an e-paper display you can add on the other side, and also it can work. It has a built-in battery management, so you can add a LiPo battery to it. So you can build a nice, neat little prototype unit that's kind of a nice form factor. So it's quite a cool little board for a pretty good price. So commercial over, I'll hand you back.
Yeah. Oh, okay. I need to re-key to my resign to my account. So I will try to very quickly go through the demo, how you can start with Amazon FreeRTOS on LPC 54008, 018. And so here, as you can see, we have a number of projects that you can configure and download. So, for example, if I will click on this project, I can choose either IR or MCUXpresso. I can basically add or remove certain library, but in this case, I'm going to be using only MQTT. So I can say create. Okay, so I already have it, so I can download it. Okay, let me change it to this one. So this is my project. Then in MCUXpresso, I already imported it, but basically in order to do that, you're going to open project from file system, and you're navigating to your expanded zip archive to the MCUXpresso project. The moment, I mean, as I mentioned, I already imported here, and I can show a few things that you will need to change. And the first thing, you will need to put your certificate and private keys. Second thing, you will need to put second header file you will need to update is for your endpoint and also for your credentials, for the Wi-Fi credentials. The easiest way for me to do that currently is to do something like this. So if I will go and I will create NXP demo. Oops. Okay. We most likely will integrate we'll integrate these tools soon. Oh, we were running almost out of time. I timed really badly.
I think we're okay to run a little bit long, Anton. So
yeah, I mean, I will need like 5 minutes longer for this.
So for people who can't hang on here, we will post the recording. It will be up within a few days. You'll get an email to let you know that it's there in case you can't hang on, have a meeting to go to or something.
So this is my thing name. This is going to be my Wi-Fi. And I'm always forgetting how what is the, so this is your Wi-Fi security options. So I can copy, paste it. And right now I can say Python setup py setup. It uses the so you will need the AWS CLI to be installed, which is pretty trivial. And right now, if we will go back here and we will go to my things, as you can see, I just created, and you can see that it's basically exactly on time. And this is the relationship between the things, certificates. So this is my thing, this is my certificate, and certificate attached to my policy. So this is my policy to onboard this device, to connect and publish from this device. I already configured this here. I mean, obviously not the credentials that we just that we just mentioned. And what I have here on my table is LPC link 2 and the LPC. Oops, it's not focusing. Okay, so it's focused right now. Just make sure that when you're going to be connecting the debug cable, your red wire going to be facing the same side as your antenna. I mean, obviously it's enumerated, so it has to be your red side of the ribbon cable have to be within the pin 1.
And I would say that's in the manual, so if people don't know that, check the board manual, which is on our web page.
Correct. So we're connecting right now the LPC link to debug interface, and we're ready to. I can clean my project, and I can build it. There are going to be few errors, and these particular errors saying that there was a declaration of certificate for the Greengrass and it was not used. So and probably another one was the just-in-time registration declaration that was not used. So those are warning. I mean, sorry, it's not errors, it's a warning. So those are safe to do. And we're flashing it right now to the board. Oops. And I'm at the first breakpoint here. So I will continue to run. And I will go to my MQTT client and I will just subscribe to all topics because I don't have anything else running. For some reason, the initial connection, it's kind of like, I think it's something with DNS here at my office. So it's actually looking for quite some time, but okay. So we have messages and we have message. So in this case, my LPC module is acting as a publisher and subscriber. So it subscribes to the same topic, and the moment it sees that I received the message, let's say hello world, it publishes the acknowledgement to that message. So in the part 2 of this webinar, we'll go with more sophisticated demo with a sensor and some transformation of messages, and also controlling the actual device. But for now, thank you very much for your attention. Thank you very much for your participation. I hope it was useful. And back to Ethan and Brandon.
Thank you, Anton. So if we could just pop back to the PowerPoint slides, we could just see where people can get more information.
Yes.
So what it's mentioning here, some other applications that we have available, like one with the Blue demo and so on for voice control that we'll be covering in other sessions. But the support, so if you need help, there's a couple places to go with NXP. If you look at the module build page, you can just go and search for the IoT based module in the search engine, or you can in the search box on our site, or you can type in the board number, which is OM40007. I just remember James Bond and add a 40 in front of it. There you can find the getting started steps, which will show you what Anton's been going through basically to get the module running. And there's also our community support site, so that's for different users to help each other out, but also we have our frontline support there as well. And there's also the Amazon resources. I don't think that page popped up, Anton, so I think it's the one before where you can
yes.
get access to the yeah, go ahead.
Yeah, you have a getting started page for NXP microcontroller. This is also the GitHub page for the Amazon FreeRTOS, and obviously you can stop by in AWS lofts if you're living in, let's say, New York, San Francisco. I mean, it's free for everybody. And also you can talk to your solution architects, and don't hesitate to use email or some community boards that we have for the support.
Okay, great. And I think, yeah, just events coming up. So we actually have the NXP Connects event this week. I'm not sure if there's spaces left in the classes, but there are classes on the getting started stuff, so you can actually get hands-on and do this yourself. There are further regional events in the US coming up, various other events through Europe and so on, in Asia as well, and coming up over the rest of the year. We did have a question from Dave here, one of the people online, asking about step-by-step instructions on what to do. And again, if you refer to the getting started tab, there's videos of going through the same steps that Anton went through here. There are a few steps involved. It's straightforward, but there are quite a few steps. So it does take a bit of time, so we didn't want to go through everything like that right here and now, so we have to go fairly fast, but you can follow those a bit more slowly on the videos. And as you see, Amazon are working on making some of those steps a little easier with the various capabilities Anton gave you a preview of here. So we would like you to join us next week. Hopefully you've registered, and Anton is going to be doing more hands-on stuff and more exciting things related to getting real sensor data to the cloud and processing that data with the AWS capabilities. And the other incentive to join us is you will get the coupon codes for ordering the boards from nxp.com next week. We've had a few people asking about getting the boards. We have got more stock moving into nxp.com, so but we also, if you can't wait, we also have boards out there in the distribution channel as well. So I think that's the conclusion of our slides. A few questions that came up online. Most of them are to do with when people can get boards and whether they can get copies of the recordings and so on. I don't know that there are any other technical questions to fire at Anton right now, but if you do have more, please post them to us on the community site. We'll look out for those and try and capture those and respond to them. If you did ask a question and you didn't get an answer today, please feel free to follow up with us there. Some of the questions were slightly off topic, so I didn't answer them just here, but we could get back to you as well. So a few people asking about the dates of the webinar. The next webinar is this time next week.
It's
so Ethan,
it's actually in 2 weeks.
Oh, in 2 weeks. My apologies. Yeah, I thought it was 1 week. It's 2 weeks. Yeah.
Yep.
My mistake.
Additionally, what I wanted to mention is that there are also a couple of videos on YouTube that NXP engineers did as a step-by-step guide to connecting LPC 54018 to AWS IoT using Amazon FreeRTOS, but in their case they've been using AR ID. So right now you kind of have both, and obviously you can pause the video, you can see what the person was doing, and also in that video it was a slightly longer path to provision your certificates, but it's not an option. I mean, we have multiple options for doing this. If there are interest, don't hesitate to shoot me an email. If you have any difficulties, we're always welcome questions. If you see some incompleteness in our documentation, please don't hesitate as well. Thank you.
Thanks, Anton. Yeah, and I did want to just quickly clarify. So you will see in the online help here, especially initially, we had only instructions for IAR and SEGA probes. So but you're not restricted to just those. There's CM, SYS, DAP, debug probes that are on the base boards. There's the LPC Link 2 probe, SEGA probe, P&E probes. All of those will work. And you can also use Kyle tools as well. It's just we obviously can't demonstrate all of those tool chains. It's just too many things. And the MCUXpresso tool is completely free, so that's why we demonstrate this one. Okay, I don't think we have any other questions that we didn't kind of already address or will need to address offline. So Ethan, if there's anything else, nothing else, I think we can wrap up the session.
Yeah, I say we wrap up. Thank you all for sticking around. But we will meet again in 2 weeks for the second part. And I don't know if you saw my answer to one of the questions, but we will have a streaming link up very shortly, later today. And then following that, we'll actually have a video up on our NXP site, along with the download link for the presentation. But with that, we will see you next week, and thank you for joining. Thanks.